Today I'm going to showcase a project that I've been working on for the Qdrant Hackathon. So since the time I have attended the PyCon event that was held in Bangalore and I went ahead and pitched about Qdrant there, one of the integral things I learned about its great functionality when it comes to the semantic search of the vectors. I pitched to the multiple people there, but this was the time I went ahead and actually experimented in my own project. So I created a project named Early for this. And why it's named like that is because it's early for those traditional search engines because it provides you the answers by semantic search. And secondly, I am a bit too early to go ahead and experiment with all of these things, but I want to pitch it like in an earlier format. I'm gonna slowly dive and make more and more into the features of this. But since we have the hackathon just tomorrow, we are going to do the summation and tell how everything are working with Qdrant. So before I dive more into that, let me go and dive into the files. So firstly, one of the integral files that we have is firstly being the quadrant service.py. So as you can see, this is the file that's open, and how it's handling one of the integral things that you will provide is of course the quadrant URL. You get that URL once you go ahead and create your cluster over there, and then the quadrant API key. All of your collections that you go ahead and create of your various documents are went ahead and posted there. At the same time, it maintains all of this cluster. And also, I've came across that it is free for your entire lifetime. So that's another use case. So everything is handled over here. As you can see, I went ahead and added some logging just so we can go ahead and showcase this much more. And here it goes ahead and creates a collection if it doesn't exist and takes all of the information. For example, what's the collection name and what are the vectors, and at the same time what's going to be the size of the vectors. Here we have went ahead and taken the vector size that is basically 384. So it's going to divide your whatever sentences and everything you have added into 384 vectors. But at the same time, want to go ahead and dive into this. So it's basically a bit of a log game. At the same time, it goes ahead and add some multiple health checks into this. So I'm gonna be lying if I went ahead and coded it all myself. I used a bit of a vibe coding, but at the same time, a lot of debugging required some kind of projects. But yeah, it helped me through. So as you can see, we have this entire file. I'm not gonna go ahead and describe it all, but we are using the geotagging as well in this. So what's geotagging? So firstly, all of your vectors at the same time that you are creating, it's necessary that you add a geotagging to it. For example, if you have a use case and you want to get only the particular searches from certain kind of longitude and latitude, the quadrant provides you this capability to add into your particular use case. So we have also added and used those geotagging of the vectors here. I'm going to show you by using the quadrant cluster UI, so you can get into a bit insight of that. But at the same time, we have went ahead, used the basic things. For the backend, we have used FastAPI, and then frontend we have used Next.js, and mostly the things are revolving around these things only. So quadrant service.py handle more of this. At the same time, if I want you to go ahead and dive into the embedding service.py, that's basically handling how the text are going to be converted into vectors. So if you want me to showcase that, so it's right here. So as usual, the texts are converted into vectors, and then of course with an embedding they are connected with each other. So here they're going to be going ahead, and we have went ahead and used this particular embedding model. So it's basically sentence transformer, and it's L6v2. Over here that we have went ahead and stated the embedding dimension is going to be 384. So your whatever sentence, everything you have added is going to be divided into 384 vectors. So as usual, the same health checks are prevailing over here, and I'm gonna show you how it's working fine. At the same time, at the end of the day, it's a search engine, but it's gonna be searching your vectors over here. So this is the thing it's gonna solve, and at the same time, for like if you add in some multiple connections, all of them gonna be pushed into the quadrant cloud, so it's gonna handle all of that. So just a simple file of that that's handling all and all of that. So we should jump over the demo side. Hmm. But before I dive into the demo side of the things, I have created some document to go ahead and depict you how it's going to work. So we have 20 different documents that's going to be going ahead and converting into their separate embeddings, and at the same time, it's also going to be pushed into the Qdrant Cloud. So we have a post and guest request that manage everything over there. So these are all the documents. For like a few of them have been divided into categories. One being the recreation, some are related to the community event side, and some are related to the events overall. At the same time, we're gonna be working on with some queries, for example, how to find like a dentist near me at the same time, or if you want to go ahead and find the events near you. But as you might be seeing, we're not gonna be finding those exact keywords, as we have this all thing vectorized and we have the embeddings in place and that are being handled by the particular geotags. It's gonna take care of all of that. So let me go ahead and take you quick to the UI. So before I take you to the UI, like it basically looks like this. As you can see, these are how all of our vectors are connected. So for example, if I will go and go into the point 11, you can see how the latitude and longitude is 40.7831, and then the longitude is this. But if I'll go just near this one, as you can see, the latitude did shift, right? So that's why these points are together. So the latitude and longitude difference is not much in between them, so that's why they are closely related. And when you're going in and searching for a query, these are the one that gets related, right? So this is how your complete documents look like over there in the Qdrant Cloud. And then, as of course, I have posted all of these collections over there here, and at the same time I have went ahead and done some requests. So let's go ahead and jump onto the UI, right? So let me just go ahead and spin it up. So it's like a simple UI. I wouldn't want to fancy over here, and if I just want to go ahead and, for example, dentist near me or events near me, just gonna search all of that. And as you can see, I went ahead and found some really interesting one. For example, a community health fair 2024, and like a local art gallery opening, and their resemblance is also being quoted. For example, a community health fair, we have 28% resemblance. We have 24% match for recreation. We have 21% match for the local theater productions. How is gonna do that? It's simply by these laws, as you can see here, where it's basically comparing all of the searches you have done, how closely it is related to the data you have entered, right? So as simple as that. As you can see, these are some of the logs. I'm gonna make it easy for you guys. So it's basically, as you can see, I went ahead, searched for a query, right? And it converted all of that into vectors. And once those vectors have been converted, so for example, you can see I searched for events near me, right? So then what it did was it creating it simple like an embedding that was the size of a vector 394, and then subsequently it went ahead and created all these results. It got like these are the results, and then ranked all of them out depending how they are rated together. So firstly, we have the simple ranking that Quadrant handles, but it also provides MMR, so it's maximum marginal relevance. So if you want to go ahead and rank it even further, you can do that. So we have different IDs we got, and then it showed that okay, we got 10 results that could be somewhat that you might be looking for, and then the score of it. So as you can see, as I quoted, this was 27% rated, so it's basically the same, like it's 27.68% related. And this is the thing. At the same time, let me tell you what are the things and the keywords we are targeting. So we have location, as I stated, the latitude and longitude of that, and it's going to tell you like what's the content it holds, and what's the category of it, what's the location, and basically other subtags that are being used, and when was the date it was created. So where does it find its actual use case is if you went ahead and go like create a kind of a recommendation model, if you at the end of the day create a rag model, everything is handled over here. As at the end of the day, all of your queries are converted into vectors, and then those vectors are simply converted to the documentation, the collections that you have added over there. So this is the result so far. And then let me scroll down a bit. The search got completed in a time span of 1190 seconds, and then you got all of these results out. Not only that, if you want to just go ahead and search dentist near me, you can do that. So it also does a bounce back. So for each kind of letter, it's gonna keep suggesting you. But if you don't want to take care of it, it's just gonna go ahead and work the simple way you want. For example, I searched D, so I got this. Okay, so it's gonna tell me okay, if you want to search to, for example, then, and I want to search for dentist near me, so it's gonna be dentist. Yeah, so as you can see, I got the result. So it's emergency dental services. This is the one that matches your particular request, and I'll give you the complete description on it. So why not we go ahead and check the logs for it. So as you can see, I'm gonna scroll down, and here it is. So I same way, I searched for a particular query. It gave me the response of emergency dental services. These are the things that you might require. These are the kind of the local documents it came across, and then your query that was basically find the dentist near me. It went ahead and converted into vectors, and then the embedding was created, and then it searched simply the quadrant vector database for it. And then if you want to go over and if you want to check your Qdrant Cloud, you can see the logs of it. So for example, yeah, these are the things you got, this is the result, these are the local documents. So everything is logged over here, so pretty easy as that. So you can just grab a quick overview and you can go and see how it works on the UI side of things. So at the same time, I'm just going ahead, like I'm experimenting on with how the vectors work, how they are all well connected, and at the same time how the particular things we are targeting. For example, we have ID that we are targeting for each particular document. So if I want to show you ID, title, content, category, location, everything we have added over here. All right, and these particular geotags is something Quadrant also takes care of before providing you the results. It, for example, if you want to see dentist near me, your particular location of a latitude and longitude is taken into mind, and then your suggestions are near about that. So it's basically solve a great use case, right? And at the same time, if you are interested for diving into more side of things, it's basically, as I stated, on the technical side, we have used embedding model. That's basically converting your text into vectors, and at the same time, it's has 384 dimensions, and more and more, it's basically around this. Uh, it uses this, and at the same time, if you want to go ahead, like dive into the technical side of things, we have went ahead and used a simple embedding model, that is v6l2. And what you're simply doing ahead is converting all of your vectors into embeddings, and you have 384 dimensions that are related to that. So each particular vector has a priority associated with it, and they are being simply compared through that. But and then if we talk about onto another side of the things, that's basically that's related to your distance calculation, we have used Haversine formula. So it's basically comparing your distances between your particular vectors. The distance we have went ahead, like the one I was talking about, the geographical location, we have used the Haversine formula. So it's simply like a formula that takes care of the Earth's curvature and then calculates the distance between two latitude longitude points and between the other two. So that's how it works together, and the all in all, the system goes ahead and provides you the result on that. So it can be used for even searching, it can be used for even recommendation systems, like considering your own geographical locations, and for simply managing the vector similarity, how the vectors are connected, we have went ahead and used the cosine similarity for this. So yeah, all in all. So all in all, it provides the search, it provides you the geographical location, it provides you capability to go ahead and add some bouncing into it. So we have a 300 milliseconds of bouncing. That's so basically before providing the results, it goes ahead and searches for this kind of thing. Like for example, TEN. It bounces back and provides you the result in that particular time frame. So all like this is the way the all the project is working. We have the all the files in place. It was a, like I'm also going ahead and kind of learning how the everything's are working, and I'm just pushing out to the community so that more and more people learn it. It went through, it's working so fine. I'm going to add more and more features. Firstly, it's going to be of course the UI, and handle how other more features are going to be working together. For example, we can add even filtering of some kind of vectors on different categories if you want that, or I'm gonna explore more onto the side of MMR. So that's what I'm pretty interested about. So yeah, thanks a lot. It's been great. See ya.